Hello everyone, Dr. I here. Today's lesson focuses on relational database table normalization. Every transaction you perform on the internet involves data. Something is always happening behind the scenes. When you send information online, you're transmitting data from one point to another. With that in mind, let's get started. Since today's topic is normalization, our focus will be on the relational database management system. My goal is to simplify this concept so that when you begin working with Dataverse using Power Apps or other data store, you'll be able to clearly understand how data is structured and stored in our DBMS environment. Our DBMS is Relational Database Management System. Remember, our final project will be based on Dataverse, and we will explore other data stores such as Excel and SharePoint list eventually in Power Apps. So, with that said, now let's begin the database normalization process. Turning to database normalization, we'll be going over repeating groups, one normal form, second normal form, third normal form, and Boyce Codd Normal Form in a moment. And what will happen in the process, in order to describe and illustrate some of my concept, especially one normal form, I'll be going into SQL Server. I installed the developer's edition of SQL Server Management System on my PC, and it will make it easier for me to bring this across. This is a little bit kind of technical, but this is necessary because if you really want to develop sophisticated application eventually, your knowledge of database itself, database normalization is important. Definitely in future, I will be creating a different topic completely on database systems, which will involve database sort of programming, installation, and all of that. But in the moment, I didn't want to include this directly with the Power Apps that I'll be bringing up to you next week. But I wanted to get this across now, make it independent such that you can always go back into. So when we have our topic on Dataverse within Dataverse, then you'll be able to refer to this separately because database normalization itself is not specific to a particular database like SQL Server or IBM DB2 or Oracle. So I just want to get that across to you. With that, let me now start the PowerPoint, the slideshow. The database normalization, as mentioned, we'll be going over repeating groups on 1NF, 2NF, 3NF, and Boyce Codd Normal Form. So what is database normalization though? Database normalization is the process of organizing data in a relational database to reduce redundancy, one, and to improve data integrity. This ensures that data is stored efficiently, consistently, and in a way that supports accurate updates and maintenance. Dr. Codd of IBM introduced this idea in 1970 as part of relational database model. So why is database normalization important? It is important because it eliminates duplicate, redundant data, prevents data inconsistencies, avoids update, insert, and delete anomalies. You will understand that in the process we're trying to create our normal forms. It improves database maintainability. It supports long-term scalability. So problems that this normalization solves, one, update anomaly, like when you change data in one place, but not others. Insert anomaly, this is an ability to add data due to missing data. You will see the example in a moment. And delete anomaly, where unintended data loss when records are removed from the systems. So with respect to the repeated groups that I mentioned earlier, In the context of database design, that is before normalization, this refers to a set of two or more fields in a single record that will store multiple values of the same type. Rather than having separate rows for each value, these values are stored in multiple columns as a list within one column of a single record. For example, an employee with multiple children or customer with multiple orders under one row. A repeating group can also occur when multiple values of the same type are stored in a single record instead of separate rows. Example, multiple employee assignment under one project row. Here's an example of repeating groups. Here we have two tables that are one of the first table here, which says customer customer table here, like customer ID, customer name, then these other columns are the one or the two or the three. And we have these two people who place orders, right? Like came in, of customer ID in the 101, and order the first order was shoes, the second was bag, the heart. Now suppose another customer just came and said, all right, I would like to have 5 orders. Now what is going to happen? You will end up adding more columns to the database table. Just imagine that if you have to keep changing for every order, then it's going to create a problem in management. Then let's look at another table here, which I call employee table, right? See what it does here. Employee ID, employee name, child one. This person has 3 children, Amina, and John also has 3 children. Now, suppose you have an employee with 5 children. What do? Then you would destroy the database table again. Then you will start trying to do that. But how do we fix this simple one for that? Now, let's just do it so that we don't keep going back to the tables and keep making changes. So what we do, let's just move it to first normal form, right? So this is how we do. We will say, okay, we're going to, rather than having 5 columns or more, then we can just have 3 columns where the first column represent customer ID, and for the first one, the customer name or the item. Then now we can say, okay, 101, Kelly has shoes, and then again bag, heart, and she wanted as many as possible. It really doesn't matter anyway. The way we enter the data is immaterial. It really doesn't matter. After that, if Kemi can come back again and said, okay, I needed 5 more orders, then you can just simply add in them to this without having to change the structure of the database. The same thing is true for this one with an employee with children. So on a person, because you go the people, some people parents prefer to have one child, or that will have more than one, and maybe 5 or 6 or 10, depends. So now you don't have to worry about keeping changing your data structure. So what I would do now, then the third one, actually, let me show you one more thing before we move here. Remember, this is a continuation of repeating groups, right? Look at this. This is beautiful, of course, right? And then we have all this data, all these records of employee with their job class, right? For June is an electrical engineer or electrical engineer, if you want to call it. And the charge hours is 84.50. And with 4.50, the hours is 23.8. Now, we assume that the next one, of course, when you look at this, then you know this is project number 15. The project name is Evergreen. And all of these people, they have their project name is Evergreen, right? Now, this is good for reporting purposes, but it's not good if you're trying to put this in a relational database management systems like SQL Server. On that note, let me show you something briefly on my computer. I have where I created all these tables in them to show you why there's a problem before we keep going to do the analysis on them, right? So if you hold on for one moment, I'm going to go to my computer and I will show you. Yeah, as you can see my screen here, I have a database SQL Server installed on my developer edition installed on my PC. And this is not a topic completely about database management systems, but I wanted to use this to illustrate the example that I was given. I did create a database called .itech and the tables that represent, remember the customer table earlier. I'm going to do, let me show you something on screen here. If you remember, I have these records here, right? About this, to show you these two customers came in and a maker having all this order, and I changed them to um one normal form where I put everyone in every order in each row or the item, which I now rename order item instead of order one or the two. Now I can have as many. And I suppose I really want to add more. I can always say one or one again, and I can say Kemi, and maybe Kemi decide to buy what else do necklace, right? Now it doesn't matter anymore. The order in which I put it really doesn't matter anymore because if I really wanted to see the order of entry into your database table is immaterial. It really doesn't matter. It just takes it. But however, when you want to display it, of course, definitely. Say, for example, if I open this, if I go select everything from customer, right? So this is going to give me like all the records you can see here at the bottom here. From customer, that's what gave me. Let me say customer N1, the one that I just enter, right? So if I execute this, you can see, however, you can see how the chemistry is sorted differently. You can see that it really doesn't matter. However, if I needed to say, all right, I'll order by customer ID now, I really want to order them, right? It doesn't matter how I write this, don't worry. So if I try to order them by days and I click execute, then it's going to put all of them in order. You can see now Kevin and everything is in order. Now, for the other one that is really, this is the one that actually, remember the last one I showed you on that was the one that has this. Let me get them up so you can see. Remember how this one looks like? Now, suppose I want to get data for the project num from this particular table. Remember I mentioned that before normalization, something is not right. Something is not right here. Okay, but it looks good because you can see it's pleasing to the eyes. You can read them. Now, if I needed to, say, for example, I want to get employee number 15, the product is on that's using, that is involved in project number 15 or evergreen. Now, let me try to do this. I say select everything from employee M, right? Yeah, right. Let's just try to run this first. In other words, I'm using query now, T-SQL. Don't worry, we're gonna get here eventually. But I'm using this as an illustration of my. Now you can see how it looks like, right? Now suppose I want to get where project num equals 1.5. Remember, um, 1.5 is in this particular case is in the character field. I didn't set it as a number. If I set this as a number, then I won't necessarily have the quotation here, right? So now let me execute. Now it says 1, and that is wrong. That is not right. There are more than one person, one employee on the project, this particular project. That is the issue now with that. So in order to make sure we got something there, let's look at this one. When I move this to first normal form, we go back to edit this. You can see how I replaced all of this. In other words, I have in each row instead of having leaving as a blank. Now I fill it up. Now, if I go into my query and needed to give me people with that number one, right? This end number is a one. That's the way I call it now. If I select, now I'm able to get the number of people, employee that are attached to project evergreen, right? So that's one of, and now you can see why you will not enter data into database to look like this. In relation database management system, you can use an Excel spreadsheet because you just want to show someone some report. For reporting purposes, yes. But when you put this in the database, it's a different story. I hope that That I just want to make that clear in my illustration. All right. Now, coming back to my repeating groups, I just wanted to use that process in the database on my computer to show you how this works. Now, we want to analyze this. You can see here, right? You can see it again, see how it looks like. Let me put it forward. So I call that figure print. The repeating group now occurs because each project normal name has multiple employees assigned to it, but all those employees are listed under the same project role without creating roles for each project employee combination. Instead, the data uses indentation of blank cells to indicate that the project is the same. In other words, you can see it uses this blank. It's saying, okay, this is the same. This is what it is indicating to you, right? So it displays the following. There's a problem with this now, right? If you see update anomalies, right? To modify class jobs for say employee 101, right? What you 101, 104, 104, you will require many alterations there, right? Then the second one where we do, like I mentioned, insert anomalies. If you want to get a new role for a new employee, right? If we don't have any project for this, we're gonna have to create one that doesn't exist. And the reason we want to do that is to, um, I mean, to at least have something. What do we call it? So it's this anomalies is bad. And the other one is a deletion anomalies, right? If employee number, say 113 quits, and we have to delete every occurrence of that employee must be deleted. This in a situation like this, we could actually lose valid data. You can see here the I changed this to one normal form, and by ensuring that all these blanks are filled with the right data, right? But there's still a problem though. This one normal form. Let me explain to you. Remember, this is great, right? This is great, but one thing is this. It is not perfect. It's not perfect. It's not what we're really looking for in real world, though, and in a production environment. Um, most places will be up to three normal form. That is, then we're going to make some changes. Look at this carefully. And here is the first number. We're going to analyze this, right? Now we have to look at this. When we go back and forth. We can see project num and emp num. These are the key. So let's go back here. See, so the key attributes are defined. We have project num and emp num, employee number, right? And then the project number now. These two combination becomes our primary key. These two combination become our primary key. And there are no repeating groups anymore because each row and column intersection now contains one and only one values and not a set of values. And each cell contains atomic values, like each cell must hold one and only one indivisible value. All attributes, in other words, the columns, are dependent on primary key. In other words, let's go back here. All these attributes now, all this emp name, all of this, now they're dependent on the emp num and project num. That is what it means there, right? Attributes are dependent on this. Partial dependencies are noticeable though. You only need to know project num in order to determine project name. You also only need to know emp num to find project name, job class to know the charge hour. Therefore, dependencies based on a part of a composite primary key are called partial dependencies. In other words, remember the two columns, project num and emp num, are the primary key. So if any of your attributes is depending on one of them, then it's called partial dependencies. You don't want that. That dependent, you don't really want that in a in a database design, but it's still acceptable. We're still in one form. Another thing that you're going to notice is transitive dependencies, which is charge hour depending on job class. Job class and charge hours are not prime attributes. In other words, neither of them is at least part of a key. In other words, it's not a part of this. So if there's a dependency between these two, non-prime, non-key attributes or non-prime attribute, then what we call them, then this is called transitive dependencies. You don't want that. So the problem with it contains partial dependencies where, in other words, a dependency that is based on only a part of a primary key, right? Because the other one is this is subject to redundancy because if I say 10 entries for an employee and one was required for emp number, job name, and charge hour, you have to enter this particular 101 repeatedly, and this is subject to error. That is the problem with first normal form. Then in order to improve upon this, there's something we call it the second normal form, right? So this is based on the first normal form where we convert it to the second. And what we do at this point now, let's look at this. So we're going to use this like now consider this a table, like we have three different tables now, which we created from that one table, right? So you're going to break it down. So the component of the composite key into separate keys such that each component now becomes the primary key of a new table. For example, project norm and emp norm. So we can divide the original table into three tables now, which we call project, employee, and assign, right? On the project now, we have project norm, column, and project name. Remember project norm, this now becomes the primary key of this project table. For the second one, the employee table now has emp num, which becomes the primary key, right? And then we have all the rest of the columns. You know, there's still transitive dependency now between job class and charge hour, just to get you at this point. But we're still in second one because remember, as I mentioned, the transitive dependencies where it's a non-prime key. It's not part of they're not part of key, the primary key, right? So they depend on each other. But we will fix this in the third normal form. The assigned table now has emp norm, project norm, assigned hours. Now you can see here we have emp norm and project norm becomes the primary key for this particular table. So the second normal form now contains the following properties. It's still in one normal form. There are no partial dependencies. Definitely we have removed that where a column doesn't depend on part of a key. So no attributes is dependent on a portion of a primary key. But note also, though, it's still possible for a second normal form to exhibit transitive dependency, right? The transitive dependency, remember I mentioned the job class and charge hour, they depend on each other, right? Or if you know the charge hour, you can know the job class and vice versa. So what we do, then we go to the next one. Now we have break them conversion to third normal form. Right now we have project table, which the project num, which is the primary key here, and the project name, which depends on this, right? The assign table has project num, emp num as the primary key, then with the assigned hours. This because the assignment now. For the employee table, we have emp num, emp name, now job class. Remember now we have removed this, we break this into now we have a job where we have job class and charge hour. Now you can see how easy we have broken one table all the way into four. This is how we try to normalize your table in order to reduce redundancy, right? In order to make it possible for data reliability and all of those things. So as you can see now, the transitive dependency in the employee table, we have removed them, which means the table is now in third normal form. Therefore, the three normal form will exhibit the following properties. It's a second normal form. There's no partial dependency anymore. Contains no transitive dependencies. So no more transitive dependencies because we have already removed this to another table, right? So now the Boyce Codd Normal Form, every determinant in a table is a candidate key. A determinant is any attribute whose table values determine the values of other attributes in a row. In other words, it's a special case of three normal form. Let's see, and by the way, BCF was a combination of work done by Edgar Codd and Raymond Boyce in 1974. So, like as I mentioned, it's a special case of three normal form. If you look at the project table here, you can see that you can see that the project table here, where project name and project, in other words, either of these could be the candidate key. So that's all there is to it. As I mentioned, this is it for now, and in future we'll be going over this as we go into Power Apps discussion. We will start gradually coming back to this to explain it. I want to separate this because last week my intention was to include this as part of the directly in Power Apps, my first Power Apps, but I discover is going to take us off the topic completely. So I just don't want that to happen. But I want to provide this anyway because we're going to be doing Dataverse part of it. That will be used eventually to develop our system. I will explain this. In fact, there'll be separate. It's part of it. There'll be really a series of topic on Dataverse and why you will need this in your Power Apps. On that little note, ladies and gentlemen, thanks for watching. See you next week.